Hello, everyone in Phys 223. This is Paula, your learning assistant for L02. I'm here with a bit of a supplemental video for you today, just going over some basic calculus, showing you how to take derivatives that I know some of you don't have a lot of experience with, so I thought that this would be useful for you. And then going over the second work together problem from this week to show you how this can be used in our class. So we're going to start with an overview of derivatives. There's a lot of theory that goes behind derivatives, which you should have seen in a first year calculus class. But if you haven't taken one of those, don't worry about it. I won't be going over the theory today. This is more of a practical scenario showing you how to take these derivatives for this course. So one of the most important rules of calculus, in my opinion, is the power rule. Power rule, not power rules. We can use this if we have some variable like x or y to the power of a number. So if we want to take the derivative with respect to x of something like a times x to the power of b, so this is saying here that x is the variable we want to look at. So there's no a or b in this expression out front here. We can just treat those as numbers in this expression here. And the derivative of this expression would be a times b times x to the power of b minus 1. So to get here, what I essentially do is take the b down, multiply it by the a in front, and then subtract 1 from the exponent. So I use these arrows to kind of help me remember how these work essentially. So looking at this in practice, if we wanted to take the derivative with respect to x of just something like 3x, we're going to do exactly the same thing in this situation. So we can say there's like a little 1 here that's kind of implied. So we take this 1, multiply it down, and then subtract 1 from the exponent. So this derivative is equal to then 3 times 1 times x to the power of 1 minus 1. So 3 times 1 is just 3 times x. 1 minus 1 is 0. Anything to the power of 0 is just 1. So this is just equal to 3. So you can see there might be some shortcuts you can do so you don't have to go through this whole process the entire time, but I do recommend you do this if you're just starting out. So doing another example, if we wanted to take the derivative of just something like 4, say just a number, again, this here out in front is telling us that x is the variable we want to look for to differentiate. So looking in this expression here, we don't see x anywhere. And if we don't see x anywhere, we can just say the derivative of this expression is 0. Again, there's a whole bunch of reasons as to why this is, but for the purposes here, just knowing that the derivative of just a number is 0. We can do this for all kinds of variables. If we wanted to say y, the derivative with respect to y of something like 4x. No, let's do y first. For y cubed, we do exactly the same thing as we would do with x. Now this is saying that y is the variable we want to look for to differentiate. So we have 3, take it down and multiply it, and then subtract 1 from the exponent. So I'm just going to make it clear that this is a y here, in case that's a little bit confusing. For y cubed, so 4 times 3 times y to the power of 3 minus 1. 4 times 3 is 12, and then y, 3 minus 1 is 2. So that is your answer there. So what happens if we kind of combine variables in an equation, say? So say we want to take d by dy of our first example here. So we have 3x. So this is telling you here that y, again, is the variable that we want to look for. if we look for a y in this expression, well, there isn't any y. It's telling us, just like up here when we first defined the power rule, we want to treat anything that's not an x as just a number. So you can think of this as 3 times 1 or 3 times 2, any number that you want, essentially. So since these are just numbers, there's no variable or y in here. The derivative of 3x with respect to y is just 0. So hopefully that makes sense, and we can move on to solving work together problem 4.02. Which is asking you to find an electric field from a potential. So this is saying the electric potential in a certain region is described by the equation V of x and y is equal to negative 1000 x squared plus 2000 y. Determine the expression for the electric field in that region. Okay, so we start out with what we know. We've learned in lecture, would have learned in lecture on Thursday, that the electric field is equal to the negative gradient of the potential. So this little upside down triangle symbol, we can call it quite a few different things. Sometimes people call it del or the gradient. Yeah, there's a bunch of different names for it. So don't get confused if you hear multiple people referring to it in many different names. And the definition, the mathematical definition of this is di by di x I hat plus di by di y j hat plus di by di z k hat. So these little curly d's, I guess you can call them, a lot of people call them di's, or you can also call them the partial derivative. With respect to x. So this is essentially just saying it's used a lot if there are multiple variables in an equation. So for example, if you have some equation such as 3 times x, y, z, and you want to take the derivative only with respect to x, you would use the partial derivative. Instead of just using d, you would use di. It's kind of just a convention type thing. And you can check for yourself. So we want to treat y and z and 3 as just numbers in this case, because x is the variable we're looking for. So then we would have, this is a 1, we multiply the exponent, 1 times 3, not x, 3y, z, and then x, 1 minus 1 equals 3y, z. Yeah, so that's how that is used there. So now we can go ahead and insert that into our equation. So we have E equals negative del, and we just write out that expression there, di by di x I hat plus di by di y j hat plus di by di z k hat. So that's the del part of this expression, and then v is given in the question, so it's negative 1000 x squared plus 2000 y. Perfect. Okay, so what I'm going to do now is I'm going to multiply the v expression into each component of this vector here. So the I hat, j hat, k hat indicates that this is a vector with 3 components. So we are just going to go ahead and do that. I'm going to write this out in full. As you get used to this, you can probably make some shortcuts and things like that. So we have negative di by di x, negative 1000 x squared plus 2000 y I hat plus di by di y, negative 1000 x squared plus 2000 y plus, oh, that should be a j hat in there, di by di z negative 1000 x squared plus 2000 y, k hat. And we take the negative of this whole thing, so we want to make sure that that is all in brackets. Okay, and now we just take the derivatives component by component. So we have a negative still, bracket. So we want to go through and look for x in this expression here. So in this first term, yep, we have an x there. So we take this 2 down, multiply it in, and subtract 1 from the exponent. So we have negative 2 times 1000 x to the power of 2 minus 1 plus, then looking at this next term for an x, nope, there's no x in there, so we just treat that as a number, and that is a 0, I hat. Exact same thing with the second term, so we have di by di y. Now we're looking for a y in this second term. Looking at this negative 1000 x squared, there's no y in there, so it's just going to be 0 plus, there's a y in this term. So we do have to account for that. Remember, there's a 1 implied here. So we use our arrows, multiply in, subtract 1 from the exponent. So we have 1 times 2000 y to the power of 1 minus 1. And that is in the j hat direction. Now looking finally at the z component. So we have di by di z. We're looking for z in this equation. In this first term, there's no z, so that is just 0. And the second term, also no z, so that is just 0 as well, which makes our lives much easier. So that is in the k hat direction. And now it's just a matter of simplifying, as you would do anytime you get an equation like this, essentially. So we have negative, the negative comes in, so 2 times 1000 is 2000. X, 2 minus 1 is just 1, so we can just leave that there, plus 0. Put brackets around this whole thing. I hat. This should be a plus in here. It's not multiplied. Plus 1 times 2000 is just 2000. Y to the power of 1 minus 1 is y to the power of 0, which simplifies to 1. So we can just leave that like that. J hat plus 0 k hat. So we don't actually have to put anything there. We can just close the brackets. Finally, we can just multiply this negative into both terms to make it look a little bit nicer. So negative times a negative is a positive. So we have 2000 x I hat minus 2000 j hat. And that should be the final answer. Oops, make my box a bit nicer. That should be the answer that we are looking for. If you look at the solution, they will get the same answer. They may get it in a slightly different way. That's completely fine. You can go through and see what works for you. So I hope this helps. If you have any questions, you can feel free to email me or reach out on Piazza. And if you have any ideas for future videos like this that you think might help, going over some basic concepts that maybe we don't have time to go over in class, let me know. Feel free to send me an email and I'll be happy to take suggestions. Thanks, and I will see you next time.